Hello everyone, I welcome you all to this 30 days masterclass series on electric vehicle design. Today is day 24, microcontroller for EV applications. I welcome you all to this session. I welcome all the participants. Yes, I welcome Nandita, Veera, warm welcome participants Bharati, Prem, Yoganathan, Mohammed, Ibrahim, Rakesh. Very good evening. Chitra, Ashat, Prince, Abdul, Sasidhar, Shankar, Ramesh. Hi, good evening. Yes, Beno. Very good evening. Yes, Jamil, Atmanand, Mohammed, Brinda. Yes, Vedant, Gauda. Very good evening. I hope you have prepared or practiced the previous EV simulation entire thing. Yes. If you have any questions about the previous class, you can post here. I will try to give you the answers. Warm welcome. So, Reagan, good evening. Yes. Lata, very good evening. Srinivasan, Ganapati, good evening. Emmanuel, Beno, very good evening. Yes. So about Pantech is a educational equipments manufacturing company. From Pantech, you can get lab equipments for EEE, ECE, computer science, IT related products. And our vision is to help 10 million students to learn the technology in easy way. So far, we have trained about 10 lakh students. It is important for the EV applications, right? So nowadays, if you take any vehicle, there are a lot of bunch of microcontrollers are used in variety of for the variety purpose, right? I will tell you one by one. So try to engage with the entire class and also how to start or how to design your own microcontroller development board, right? So that is not a big rocket science. I will share you one by one, so try to engage with the entire class, right? Yes, if you have any, what is the last date purchase internship course? I mean this 30th day. 30th day will be the last date. Self-driving car is practically implemented anywhere. Yeah, see, actually, self-driven car, autopilot mode, Tesla has successfully implemented. So the autopilot mode is perfectly working for their vehicles up to 70%. Still, that a human assistance is required. 100% self-driven car is not approved in the commercial, passenger vehicles. For the passenger vehicles, 100% is not approved. Whereas the 70%, where actually even though if it is a self-driven, then the human assistance is required. Right. I hope I answer your question. Right. So now, what is the automotive electronics? So why? What is the main difference between the basic electronics and the automotive electronics? Do you have any idea? So what is the main difference between the basic electronics and the automotive electronics? So while you go through the resistor behaviors, in the resistor there is a two parameter specifications. One is that resistance value like 1k, 2k, 3k, 4k, something like that. Similarly, additional information also will be mentioned, but I mean for the low power, for the consumer electronics, we won't bother about that. Resolution, right? So whereas in the defense applications or automotive applications, we will bother about that part. So the resolutions are nothing but see, actually there will be a yes, automatic. Yeah, so there will be a percentage. So 5% or 10%, something like that. So we have to choose based on that value. So when you choose the low, low resist, low, what word I forget. Yes, resolution. Yes, there are two things. Just a second, I will tell you the name of. And yes, yes. Just to go to digikey.com. So there will be a detailed components purchase. Just to go to here, go to DigiKey components. So here you can get complete information about it. Research resistor. Here you may get a variety of components. For example, if you take this one, take throughput, and see here for example, one let us take 1 ohm or few ohm. So suppose if I am going to take a 8.1 kilo ohm, right? So in this 8 kilo ohm, there are the plus or minus zero point 0.1 tolerance. Similarly, you have a 1 tolerance, and yes. So for this resistance, only one these two things. So similarly, if you take this one, if you take any other components, oh yes, 28 something like that, 0.1 ohm and then 1%. So this is called tolerance. So for the normal electronics or consumer electronics, you can go with 1% of the tolerance. Whereas in the automotive electronics or defense applications or marine applications, you have to go with 0.1% tolerance, which means that 8.07 k ohm will be exactly, so there may be a 0.1 percentage variations may be there in that particular resistor. Whereas if you choose this resistor, then here the 1% tolerant, 1% variation may be there. 1% variations may be there. So here, for based on the applications, you can choose the tolerance value. So if you choose the accurate resistor, then the cost will be high. If you choose the nearby, if you are allowing a plus or minus 1% or 5% or 10% or 20%, based on the percentage which you are allowing as a tolerance, then cost will be very less. So now if you take automotive electronics, so here whatever the electronics used in the transportation industry, so that's all called automotive electronics. But those electronic components which is highly reliable, and then it's temperature acceptance. For example, for the normal commercial or consumer electronics, the electronic temperature value, that particular components can withstand the temperature, or it can accept the temperature from 0% to 85%. Whereas the industrial grade minus 45 degrees Celsius to 100 degrees Celsius. Whereas the automotive electronics, it should support minus 40 degrees Celsius to 125 degrees Celsius. This is the standards. For the military grade applications, military grade and then marine applications, then we have to use minus 55 degrees Celsius to 125 degrees Celsius. So this is a range. So whatever the electronic components used in the automotive applications, so you have to keep this temperature as an important specifications. Because in the EV, there are microcontrollers used to control your motor. There are the microcontrollers used to control your additional accessories like infotainment systems, and then wiper control systems, and then automatic door systems, and other sensor applications. So for these applications, we have to use any one of the microcontrollers. So for each and every applications, we have to choose the particular microcontroller. I will tell you one by one how to choose the microcontroller also. Right? So try to engage with the entire class. Yes. If you have any questions, you please comment. I will try to give you the answers. If you have any questions, you can ask me. I will try to give you the answers. Right? So in the history, Volkswagen only, 1968, they have introduced the automotive electronics for the engine control unit. So that is the very first part they have introduced. So to control or to increase their engine performance, they have implemented that electronics. So from that point, so nowadays, you take any vehicle, so there is a only electronics part only there. So for each and everything, the electronics part plays a major role. So in the electronic part, again, then there is no any complete rocket science. Any one microcontroller will be there, and then communication port will be there. So in the microcontroller, we will do some logics. So based on the applications, we will do some logic. So I have one case study how to do that job to try to engage with the class. Right. So if you take if you take a vehicle, so like either conventional vehicle or EV vehicle. So here, see here, there are plenty of applications are required to implement with microcontroller. For example, entertainment systems, battery management systems, land corrections, electronic toll collections, and then digital turn signals, navigation system. See, for example, if you take any one of the applications, if you take digital turn signals, see here the digital turn signals in the driver control, so there will be a left and right control signals. So see actually here instead of moving your hand, so simply just you can implement a gesture to enable the right indicator or left indicator. So those applications needs a microcontroller. For that applications, you need one gesture sensor and one microcontroller. So the microcontroller will recognize the gesture sensor. So based on your hand gesture, the microcontroller will take a decision, right? So once if the microcontroller take a decision, then the system will exit. Like in the vehicle, so we will keep two type of lighting systems. So based on your gesture, the microcontroller will enable left or right based on your input. So this is very simple application. So like that, all the applications requires any one of the electronic circuit. So while you choose the component, you have to choose the either automotive grade or industrial grade or defense grade or marine grade or consumer grade. So based on that, again cost also may vary, depends the applications. How to purchase this type of electronic parts? That's why I told you I will show you how to purchase these things. Please wait. I will share you the information. Right. So now as per our requirement, so without embedded system, without microcontroller, we cannot do anything. Right. So without microcontroller, we cannot do anything on the vehicle. So microcontroller, what is a microcontroller? So if you want to learn the microcontroller, then you may hear the name about embedded systems. You may hear the name about the embedded systems. Do you have any idea about the microcontroller or embedded systems? Do you have any idea about the microcontroller or embedded systems? Can you please comment? I'm just waiting for your reply. I'm just waiting for your reply. Can you comment? Do you have heard about the name of microcontroller or embedded systems? Simply, you can take the embedded system will work based on the software plus hardware, right? So software plus hardware. So with the embedded system, so we have to develop application in the application code in the software. That code needs to be implemented in the hardware, right? So this is the embedded system. Before getting into the embedded system, you must know what is embedded system, right? So in the embedded system, any one of the controller will be there. So the controller will receive a data from the sensor, and this sensor will feed the data to the microcontroller or any simply we can call it as a controller, because in the before discuss about the microcontroller, there are a few more concepts also there. I have scheduled that too, so please wait. Yes. See here the controller. The sensor will enable you to sense the physical parameter, right? And from the sensor, we will keep one signal conditioning circuit. So that circuit will give you either electrical voltage or in the form of current. So again, that depends the sensor type. We have to choose. Once the data reach to the microcontroller, so the microcontroller to work to apply a logic, then you have to develop a application code. So then generally we can call it as an application code. So that code needs to be downloaded to the target applications. Once if you download it to the target applications, then your system will get ready to function. right? So this is the basic embedded system. In the embedded system, again there will be a input for the sensor integration, output for the either communication port, or you can display the signal in the local itself, in the target application itself, right? So if you take this airbag system in your vehicle, if you take airbag system in your vehicle, see for example, now you have to verify the situation, right? See here the weight sensor and then occupant detections. So these two things are the sensor detections. Whenever the vehicle get into the unwanted situations, that sensor will detect whether the people are there or not, right? So this will trigger one interrupt to the microcontroller. So this microcontroller will keep on monitor whether is there any input are coming or not. So whenever you are switch on your vehicle, automatically the microcontroller will monitor the particular pin, whether that is there any input or not. So when the input is enabled, then automatically it will take a call, right? So like that we will develop applications. So for that one, so this is the microcontroller part. So we can take a microcontroller part, and other things are the communication parts. So these are the communication parts, because the sensor will be placed somewhere, and then main circuit will be placed somewhere, and we have to communicate the informations, right, each other. And so the motor is sealed, but this is the action. So if there is unwanted things happening, then the airbag system should get enabled. So this is the generalized idea. So for to achieve this one, you have to develop application code, and then you have to develop a very first microcontroller. As a EV engineer, you must know how to design your own microcontroller application board very first. So if you take any microcontroller, there will be a minimum requirement like a power supply and operating frequency. Generally, if you take any processor or microcontroller or DSP processor, there will be speed. So that speed based on your physical input or clock input. So generally we can call it as a crystal oscillator. So do you know the 8051 microcontroller? Do you know the 8051 microcontroller? So if you have a 8051 microcontroller, so there is very few things. One is that clock. If you the clock crystal oscillator input, and then power supply and transceiver port, like a transmission and then receiver port. So if you enable these three pins, then you can develop your own microcontroller board. To develop this one, then you can develop your own microcontroller board. I will tell you one by one. So please try to engage the entire class how to develop that too. With the PWM, we are implementing for microcontroller. Yes, Mr. Prasant, the PWM we have to develop an application code. Right. So now, see again in the embedded systems, other things required like input and then output data memory. So these are all additional requirements. To understand these concepts, so first you should know what are all the basic essential components for the microcontroller. So one is called that is the instruction set, and then memory. So if you develop application code, then you should store somewhere in your microcontroller, right? So that is the memory type. So again many types are there. So based on the microcontroller you can select it. And so how the application codes are working. So there are very basic architecture. So one is called von Neumann architecture and then hardware architecture. So if you want to communicate data to the microcontroller, then if the data and then address lines and then data are traveling on the same path, then that is called von Neumann architecture. So that is called the serial architecture. Whereas in the hardware architecture, so there will be a parallel architecture, parallel lines. So both the address line and the data line will have a separate lines, so that we can increase the speed of the operations. So this is very basic microcontroller. So nowadays, if you take any microcontroller, so separate lines are there. For now, for advanced SBC models, there are a lot of facilities are there. And so to understand the working principle of microcontroller, or see actually you must know what is a microprocessor. See, in the microprocessor and central processing unit or ALU will be the single chip. If you take this one, just to go to 8085. So this is a microprocessor, right? So this processor will be a single chip. So in this entire chip, there will be a ALU model. So additional thing, what are the things do you want? Like input, output communications, that is called the peripherals, and sensor integrations. For example, if you want to connect a digital input, then you need a digital sensor, that is a digital IO interface model you need, and then communication models. So all these things you have to add additionally. All these things you have to add additionally. So that is the this slide shows. CPE will be the entire IC, and for memory will be the separate peripheral, and then data will be separate peripherals, and then input and then output peripherals. Everything will be separate peripheral. So to connect to interface these things, then the separate address line and then data line will be there. So you have to enable it. Similarly, if you take a microcontroller, and just to take, yes, so 8051. So this single IC will have all the peripherals. So ALU will be there, and in addition to the ALU, additional peripherals also will be there. See here in the microcontroller, ALU, this is the ALU, and then memory, and then timers, ADC, CAN, and then parallel port, UART. So all these things will be available within the chip itself. So only thing, you have to develop a code and then you have to access it. For each and every interface models, there will be a registers. Simply you just call the register, and then you can assign the register, and then you can get developed your application code. Right? That is a major difference. So in the microprocessor, the IC denotes that only the ALU. So all the peripherals you have to add additional ICs. Whereas in the microcontroller, the single IC will have everything into the single IC. Right? So what is radars? The radar is again it's an additional sensor to sense the whether the object is reaching very near to or not. Right. Similarly, how you can choose your microcontroller for your applications? How to choose the microcontroller for your applications? Right. So there are based on the application type you can choose. And then if you take standalone applications or real-time application, networked application, and then mobile applications. So these are the type of applications. Standalone applications. Can you tell me any one of the applications for standalone? Standalone applications. Can you tell me any one name of the standalone applications? For example, if you take automatic door closer, so that is one standalone applications. If you enter, then the door should open. If you leave, the door should close, right? So for that only one sensor is required for entering or leaving the detections, leaving functions detection, and then enabling the rotor, so enabling the motor, right? So this is a standalone applications. Similarly, the real-time applications, whereas wherever the time involved. Accurate time involved. So that requires more. That is called RTOS based applications. Multi-functions is required. Similarly, bunch of standalone applications needs accurate timing calculations. So for that applications, then you can choose it. Similarly, for the networked applications. So there network application, the bit rate and then file transfer data, file size. So based on this you have to choose. For example, for standalone applications, very basic microcontroller is enough. Whereas if you take a DigiKey, see this is the DigiKey is the best platform to purchase any microcontroller. Any electronic components. Actually, in our laboratory, we use DigiKey website only because here we may get exact components as per the manufacturers. For example, if you take a microcontroller, search microcontroller, embedded microcontroller. Here about 3600 microcontrollers are there. And now if you choose the value, right? So each and every microcontroller will have different pricings. So of course we have to verify the cost, right? So without cost we cannot straight away we cannot purchase it. For example, if we take this microcontroller, so it's a 245 rupees, right? Similarly, if you have for example, yeah, if you take this one, so this is a 403 rupees, 403 rupees. If you for the standalone applications you have to choose very low cost applications, is low cost microcontrollers enough, because we don't require any timing sequences, we don't require any ADC facility, we don't require any advanced communication protocol for standalone applications, right? So in that case you can choose the low cost processors. So the low cost nothing but in the all the microcontroller manufacturer will have same controller with the different pricings, because the memory will be very less memory, they will use very less memory. For example, I will tell you pick 16, yeah, 16F877, right? You search that microcontroller, search pick 16F877. If you search this microcontroller, yeah, my god, here I need only the microcontrollers, right? See, there are different packages. For example, the PIC 16F877A. So this is a different package. This is called the BGA pack, and this is the through-hole pack. So this cost is 480 rupees, and then this cost is 580 rupees. So here you may get 100 rupees is the difference. So while you're going for the bulk productions, then the each and every rupee will be a cost of the will play a major role in your product pricing. So you have to choose based on the requirement, right? So here you can verify the number of this 8-bit is enough, and then speed of the microcontroller is enough, and then what are all the communication ports are required, and the number of IOs. So everything you have to take in care, right? So now, and similarly the network applications. For the network applications, there you need a high speed communication port. So for example, TCP/IP communications or CAN application, CAN protocols, or else one more for EV applications, the link, CAN link. So those two are the main protocols. For without data loss, we can share, where we can transfer the data. So like that we can develop, right? So for the mobile application, of course, we need a SBC model, single port computer model. And similarly for the embedded types of embedded systems, based on this one also we can classify our applications: small scale, medium scale, and then sophisticated embedded system. Again, based on your applications you can select it. So here there in the microcontroller there are a type of bit: 8-bit, 16-bit, 32-bit, 64-bit. For example, if you are developing a self-balancing vehicle, in the self-balancing vehicle the ADC data may require huge size. If you are wherever the ADC is required accurate manner, then you have to go for the higher bit resolutions. So in that case, you have to go for the 64-bit processor. Other than that, you can choose any low cost. If you keep on increasing the bit operating size, then you have to bear the cost. Similarly, the memory also, right? And bit ADC bit resolutions, and then speed. So this based on this data, so you have to choose your microcontroller, right? Yes. So here for these applications, ADC is the important parameter, and then communication So here we have to use the CAN and the link communications, and then speed. So the system should be a high speed. So instantly it should take a decision, and then cost. So based on this, you can choose your microcontroller. Based on this, you can choose your microcontroller. Right? Is it clear? Is it clear how to choose the microcontroller for your applications? Can you comment? If you understood the concepts, please comment in the comment box. Super clear. If you understood, please comment in the comment box. Super clear. I will share you the attendance link. Just a second. I will share you the attendance link. Yes. Thank you, participants. Thanks for your comment. Just a second. I will share you the attendance link. Please get it. I pinned the message. Yes. So the attendance is available at the top of the chat. So please check once again. So based on, this is the very basic methodology to choose your microcontroller for your dedicated applications. And yes, Mr. Ashish Kumar, after this live, please WhatsApp me. I will give you the solutions. 8409744408. So these are the top 10 manufacturers. So just to have this, just to have a look on these websites. Take a note. Renesas, they are the Renesas and the ST. They are the top manufacturers on the EV. Automotive industry. Automotive industry. And then ADC type of applications. Then analog people are playing a major role. And again, a few more companies are there. So just check and then have a look on this. I recommend you everyone, please visit these pages, then try to explore what are they doing and then what is the reference designs, everything. You please refer it. Right? And in the Texas Instruments, they are specially giving EV applications. So they are providing the C2000 based application boards. Actually, in Pantech, you may get C2000 based application boards. PMS, yes. Here, the Pantech, you may get it this kind of boards. So in this, the TI also will give you. The TI also will give you the detailed reference design how to develop our applications. For example, onboard charger and then DC to DC converter, traction inverter, DC charging stations, automotive HV AC applications. You may get a complete reference design. I will share you the complete reference designs. So just, I will share you in the web page. Just a second. I will share you the things. I recommend you please visit the page TIOBC reference. Yes, I shared the link. So please visit this page to get know about what is actually they are providing. See, for example, Piccolo 28027 process, you may get a single board, single phase OBC charger, and then high voltage motor control application. This is the perfect processor. And see, for example, 3709D. So this is the high 4400 to 800 MIPS million instruction per second. And see here, you can go combined 3-phase OBC and then high voltage DC-DC converter and then dual motor drive. So this single chip can support this entire work. This single chip can support for the entire work. Of course, the cost also may high. Right? So this is the requirement. So you can use it. Sir, yesterday attendance not open. Please send my mail link. See, actually, how you can ask like this? See, yesterday attendance you have to get yesterday class only, not this class. I'm new on this. Please guide me. See, this is the 30 days master class. So it's a free on the YouTube internship. You can join. You have to pay 598 rupees. So free classes almost 23 classes has been closed over. So from this, if you want to start, then you have to join the internship to get all the classes. So as that internship certificate, you can get it, right? And if you cost wise, if you take a comparisons, the microcontroller will be a less cost than the FPGA, whereas the DSP little bit higher. Similar wise, the performance also you may get a rugged performance. Right? And how to design the target microcontroller board. So how you can design your own microcontroller board. So very first I told you, right, you have to choose the microcontroller. And so this is the crystal oscillator. So if you take any microcontroller, for example, just to go to Google, take 8051 microcontroller datasheet. Just open the datasheet. See, for example, in this microcontroller, if you have a clear idea about these pins, clear idea about this pin. Just a second. See, for example, as we require the power supply. See here the ground. So this is the ground pin, and then similarly the power supply. See here, this is the power supply pin, and then this is the reset pin, and you may get detailed information about the pin in the data sheet. Right? Then this is the power supply, and this is the crystal oscillator. So if you know these three basic parts, then you can develop your own application board. So for that one, so just go to the data sheet. Just go to the data sheet and go through all the pin details. Just go through all the pin details, and if you go through the pin details of each and every pin, if you go through the pin details of each and every pin, so here you have to like identify the proper reference circuit. For example, I will share you. Okay. Let us take any one of the power supply. So these are the register values. Yeah. Here they have mentioned the how to program the flash memory. So here this is the crystal oscillator. So from this one 3 to 24 megahertz you can apply here. So this is the capacitance, you have to connect it. So in between you have to connect as a ground pin. Right? So in between you have to connect as a ground pin. So this is the clock oscillator. Similarly, the input, positive and the negative, and wherever it is required, you can connect it. So if you connect this one, other things are the additional features. Other pinouts are the additional features. If you prepare this circuit, then you can straight away you can go for the application code, and after that you have to connect input, output, and all based on the requirement. So this is a very basic point to kickstart your applications. In our Pantech, actually in IoT masterclass, we have given the clear information about how to develop your own microcontroller, and then how to do the PCB courses and all. If you are interested, you please call me or WhatsApp me. I will share you the link so that you may lead. You can reach the better level for the PCB designing, right? And second, how to select the microprocessor. So there are different type of processors are there. So DIP and then QFP, SOIC, PGA. See here, the soldering iron is enough to solder the DIP packages. Whereas the BGA, in the handle there is no any possibility. So for that one, you have to use the stencil. You have to prepare the stencil. Then you have to dip into the oven. Then that IC will get solved. Otherwise, it will not get soldered. So we have to go one by one to choose that one. But actually in Pantech, what we do, we will prepare the schematics and we will do the layouts with any one of the tool like Cadence or Allegro software, and we will procure the PCB with the from the PCB manufacturer, and we will outsource to the assembly house. So we will procure all the components from DigiKey, and then we will procure the local components as well as the international components. And cumulatively, we will release the BOM to the PCB assembler. So they will solder it behalf of us, because the assembler will give 0% effective components. So manual soldering will not work. So we have to go for the CNC machine based soldering. And so this is all the idea. You have to select the processor. So first you have to identify the development tools. If you take a 8051 microcontroller, there are a lot of things are there. Atmel is the very first one. Now the microchip is providing the programming or environment method. And number of IOs you have to select, and then performance, cost, operating systems. So these are all the points you have to keep in your mind while you select the processor. How you can design? First you have to design the schematics, and then you have to move to the layout, and you have to once if the PCB reach to your house, then you have to go for the assembly house. So once the assembly house over, then yes, so these are the layout consideration. Just leave it. So once the assembly house over, then you have to go for the debugging mode. Download the application code. Just download the application code and then debug your hardware. And how you will debug it? Before you get to the debug, then you need this kind of the emulator. This is called the emulator. So in the software we will call it as a simulator, and this is called the emulator. So the real-time code you can get as a data from the hardware, right? So here you may get a real-time data in the hardware. So that for that purpose the emulator will help, so that we can debug the application code in the real time itself. So like that we can develop one by one. Right, and finally you have to go for the cabinets. So there are two methods. One is called the 3D printer method. For one or two components you can use the 3D printer concepts, and for the high quantity requirement, then you have to go for the CNC based machines. Then you may get a very less cost, but you of course you have to invest last in the initial investment will be huge. And test zig. So for the bulk productions, the test zig is the best method to initially test your board for power supply, and then clock, input output, and then short. Is there any short, something like that. So for that applications, the test zig will help us. Test zig will help us a lot. Right? So if you have any questions about these things, please comment and I will try to give it. Can I message you on WhatsApp? Yes, you can message me. You can message me. Will these notes be shared with us on internship? Sorry, for the internship users, they can download it from the internship portal. Yes. Have any more questions you can ask me. So now, how to where you can start your microcontroller programming? How and which point you can start your microcontroller programming? So for that one, so just to take 8051 is the very basic microcontroller you can start, and for the programming part, uh, script programming and then graphical programming, right? So these are all the two programming methods. Whereas if you are if you are comfortable with the script programming, straight away you can go with script programming. There is no any issue at all. Attendance link is in the top of the chat, so please check. And the graphical programming, see here, we are giving you the graphical programming concepts. I will tell you one by one. See here, I have prepared the video. Can you able to? Just a second. See, for example, can you able to see this? See this board. Can you comment? Can you able to see this board? Yes. See, for example, the Arduino microcontroller, and then this is the display like a CRO. This is a like CRO, right? So now this board can be programmed via the MATLAB. So this is already done with with MATLAB Simulink. So now I'm just going to share this information. So see, for example, if you take this MATLAB Simulink, yes. So here in the MATLAB, you can just add these components. Right away, you can download the card hardware. See, for example, whatever you want to develop a PWM, pin number 3, 2, 5. So based on the logics, IO logic, you can select it. IO logic, you can select it. So detailed step-by-step video is available on the internship portal. If you are really you want, please go ahead. Right? And you can straight away you can download it. So here just see this video. The PWM has been generated. So how to develop a step by step a PWM, everything is available on the video. So please go ahead if you are really required. So this is the graphical programming method. So the Arduino is the best controller to kickstart your applications. Again, Arduino will not enough to fulfill our EV applications. But this is the very starting point to kickstart your microcontroller application. Right? So like this, you can develop your applications. Yes. So just take this portal pantechelearning EV. Yes. Just have a look on this. You may get it. Yes. Use the coupon code to get your discount. So like that, you can go and then you can download all the project files. So wherever it requires, you can download it. Yes. Here you can download all the content. You can download the simulations, that is the MATLAB files, and then you can download the PPT so that you can use wherever you want. Right? Have any questions you can ask me, I will try to give you that. Manu, Pantech e-learning, I attended data science masterclass, but I cannot receive a certificate to me. So for that you have to submit 25 days attendance. Then only you will get a certificate. Otherwise, how you can get a certificate? Without attendance, how you will get a certificate? Right. My WhatsApp number is 98409 74408. Can we manufacture the board at home? How to purchase it? See, actually, components local purchase. Some websites are there. Just go to websites. Component. Here, these are the best guys to purchase the component. Yeah. Here, these are the best one to purchase the components, and locally you can get all these things and procure it. And in the Pantech, you can get a PCB design course. So you may have a PCB design course. You can just have it. If you are interested, you can go ahead. Right. Now you can ask your questions. If you have any questions, please ask me. I'll try to give you the answer. And I hope this class gave some idea about the microcontrollers and then our EV applications. And if you have any feedback, so please share your feedback to this number, to my WhatsApp number. The job opportunities in EV, there are plenty of job opportunities are there. Only thing you have to crack the proper way. Yes, if you have any questions, you please ask me. I'll try to give you the answer. Thank you, Archit. So please share your video feedback to my WhatsApp number. So this is my WhatsApp number 98409744008, and I will try to give you the answers. Thank you, participants. Thanks for your valuable time, and we will meet you in the next class tomorrow. Tomorrow we will meet you. Thank you once again, participants. I will share in the attendance and then internship portal link will increase. Thank you, Jamil. Thank you.